Yeah, always.
Alright.
So, what's your name, man?
Terrell?
Good. Nice to meet you. I'm Ben. So, our question for you today is the North Star the brightest star in the sky?
The North Star.
Yeah.
I believe it is not, although I do not know which one is.
No, that's right.
Yeah.
And actually, the reason why the North Star is important isn't because of its brightness, but because of its importance in navigation. So if you look up and you see the North Star, which is called Polaris, something like that, there's much brighter stars in the south sky and in the other parts of the sky. But it's important because of navigation, so thank you.
Sure, no problem. Good luck.
All right, man. Nice to meet you.
Nice to meet you.
Thanks for coming out.
Yeah, sure.
Just got one quick question for you first.
Absolutely.
Can you explain to us the difference between astronomy and astrology? I mean, are they basically the same thing, or is there a difference?
Well, they are not the same thing. There is a difference. Astronomy is the actual scientific study of stars and planets and the universe.
Right.
And then astrology, has to do with mythological, storytelling and based on when you were born. It depends what kind of personality you'll have. All that kind of stuff.
Yeah.
All that stuff, I guess. So there is a difference.
Right. You got it.
You got it. Thank you.
Man, sure.
What's your name? Nice to meet you. My name's Robert. So, I just need to ask you, do you know how many stars are in our solar system? Well, actually, that's a common misconception. There's really one star in our solar system, and it's the sun. But, yeah, people think that all the time. There's actually, hundreds of billion stars in the universe, but in our solar system, yeah, there's only one.
All right, we can ask you another question.
Okay.
How many stars are there in our solar system?
In our solar system?
In our solar system.
I think there's one.
One. Right. Just the sun. Got
You
it.
got it.
You got it.
Great, thank you.
All right, thank you.
Nice to meet you, Ben.
The Hall of the Sky establishes each person's connection to the primary object in our sky, the moon and the sun. The end of the hall is anchored by one of the largest public solar telescopes in the United States. Celestat and solar telescopes. Griffith Observatory's 3 solar telescopes bring the sun directly to visitors in the west rotunda of the Hall of the Sky. On clear days, each of these telescopes provides a different real-time view of our local star, including sunspots and solar flares. The 3 beams of sunlight for the telescopes are focused into the rotunda by a triple mirrored tracking device, called a celestat, Latin for sky stopper, which is located in the western dome of the building. The solar telescopes operate only during clear daytime hours. Celestats are often used in solar observatories, where moving small tracking mirrors is preferable to moving large telescopes attached to heavy equipment. Designed by Russell Porter, whose drawings served the basis for the 200-inch telescope at Palomar Observatory and Griffith Observatory, the 3 mirrors of the observatory celestat move continuously during the day to remain focused on the sun as it appears to move throughout the sky. Scaled models and animations show how the proximity of our local star, the sun, is critical to our lives and helps us study the nature of all stars, the engines of the universe. One of the largest and most visited... Hi Robert, thanks for coming out today. And I just have one question for you today.
Yes.
All right, Robert, my question is, why is the sky blue?
I think it's the way the light reflects off the particles in the sky, the particles of dust or whatever matters in the sky, and it bounces back at your eyes as blue.
Well, not really. The blue color of the sky is actually due to Rayleigh scattering. As light moves through the atmosphere, most of the longer wavelengths pass straight through. Little of the red, orange, or yellow light is affected by the air. But most of the shorter wavelength light is absorbed by the gas molecules, so the absorbed blue light then gets radiated in different directions and scattered all around the sky. So whichever direction you're looking, some of the scattered blue light is reaching your eyes. So since you see the blue light from everywhere overhead, the sky looks blue.
Alright, thank you.